Okay, here we go. Last set of notes for Unit 1. So take a moment, pause the video, and fill in this table. So copy down the table, fill it in as best you can, then we'll walk through it together. All right, so here we go. Log base 4 of 10 plus log base 6 of 10 equals log of 80. That is false. So the reason it's false is because we have different bases, 4 and 6. If they were all the same base, so like if this were 6 and this were 6 and this were 6, then yes, it would be true. Because they are different bases, it is not. Whereas in this one, it is the case. We have the same base, we're adding logs, so you multiply what you're taking the log of. Here, the log of x over 3 plus x equals log of x minus log of 3 plus x. That is true as well. So when you are subtracting logs with the same basis, you divide. Log of 0 equals 0. That is false. A log of 0 is undefined. And here, log of x to the 5th equals 5 times log of x. That is true. Whenever you have an exponent, you can bring it out front. Or wait, oh, actually, my apologies. No, that is false. So if that exponent is on the inside, so if it's on what you're taking the log of, then you can bring it out front. But since this is not, what we essentially have here is log of x times log of x times log of x times log of x times log of x. My bad. So this is taking log of x to the 5th, so multiplying it by itself 5 times. Okay. All right, so the focus for today is on logarithmic and exponential equations. So to solve logarithmic equations, which are equations that have an x with a log, or exponential where your exponent is a variable, it's helpful to convert either way. So as a reminder, so the log base b of y equals x would be the same thing as saying b to the x equals y. This is how you convert from a logarithmic equation to an exponential equation. So that's what we're going to do here to start. We're just going to convert from logarithmic to exponential equations. So we have the log base 6 of 1296 equals 4. So if we're converting this to exponential, it becomes 6 to the 4th equals 1296. So these are true statements, but you take what you're taking the log of to the power of what it's equal to equals, or sorry, you take the base to the power of what it's equal to equals what you're taking the log of. So here, 2 to the power of negative 3 would equal 1/8. Again, that's true. Here, x to the power of 2 equals 81. So this is a situation now where we can solve for x. Let's take the square root of both sides. We get x equals plus or minus 9. Remember, taking the square root, two answers, plus and minus. Okay, so converting from log to exponent. So you've got 3 more. Give those a quick try. Pause the video, write them down, give them a go. All right, you've had your chance. 17 to the power of 2 equals 289. 169, sorry, to the power of 1/2 equals 13. Remember, anything to the power of 1/2, same thing as the square root, so we know that's true. And here, 2 to the power of x equals 8. So with that in mind, what does x equal? 2 to what power gives us 8? 2 times 2 is 4, times 2 is 8, so 2 to the 3rd, so x would be 3. Okay, so this is how we convert from logs to exponents, and we use that to solve logarithmic equations. So that's what we'll do here. So we have 3 equations. You can pause the video and write them down if you want. When we're solving here, we convert from log to exponent form. A key thing to remember with this is you can only convert if there is no multiplier. So you can't be multiplied by anything out front. You can't be like adding something. It can't be like 3 plus log base b. It's got to be just the log on one side of the equation to convert. So when we do this, notice we have that already, so we can convert this into 4 to the power of x equals 16. And we just think 4 to what power gives me 16? 4 squared. So that means x equals 2. Over here, this is an instance where we have a multiplier. So to actually figure this out, let's start by dividing everything by 7. So we get log base 3 of 1 equals x. So in this case, our x is not on the inside. So there are a couple ways to think about it. We could convert, so it'd be 3 to the power of x equals 1. And 3 to the power of what gives us 1? Well, anything to the power of 0 is equal to 1, which makes x 0. Or we just know that log base 3 of 1 is 0. Whenever you're taking the log of 1, it's always 0. So either way. Probably coming more in handy, this last one. So we have the log by itself, so let's convert to exponential form. So we have 2 to the power of 4 equals 5x plus 1. 2 to the fourth, well, 2 to the first is 2, times 2 is 4, times 2 is 8, times 2 is 16. And now we have a pretty simple two-step equation to solve for x. Subtract 1 from both sides, we get 15 equals 5x. Divide both sides by 5, we get x equals 3. Okay. All right, not too bad. You've got 3 more problems here. Please go ahead, give those a try on your own. Okay, write them down, pause the video. Okay, here we go. So since we have that log by itself, let's convert. So it'll be 5 to the third equals 5 plus 4x. 5 to the power of 3 is 125. Minus 5 from both sides to get that 4x by itself. So we get 4x is 120. Divide both sides by 4. 120 divided by 4 is 30. So we get x equals 30. Over here, log of 3x minus 2 equals 1. I don't see a number there. What's our base? So when you have just a log, that's the same thing as base 10. So we may think it's a 1. That's not the case. If it just says a log, that's the same thing as base 10. So when we're converting, this will be 10 to the power of 2 equals 3x minus 2. 10 squared is 100. Add 2 to both sides, we get 3x equals 102. Divide both sides by 3, and we get x is 34. Okay, last one here. So in this case, we don't have the log by itself, we have this 6. So let's divide both sides by 6. So we get log of 2x plus 6 equals 12 over 6, which is 2. This one's a common log again, meaning we actually have a log base 10. So 10 squared equals 2x plus 6. 10 squared is 100. Subtract 6 from both sides, we get 94 on the left, 2x on the right. Divide both sides by 2, and we get x equals 47. Okay. All right, so that's solving like a few steps with logarithmic equations. We will ramp it up a little bit here now. And we'll solve these logarithmic, and then we move on to exponential. We're doing great. So you can pause the video again and write down these problems if you'd like. Okay. Here, number 1. Again, we have common logs, so log base 10s. In this case, we have 2 logarithms. So we cannot just convert to exponential form right away, because remember, to convert to exponential form has to be just a log equals something. So in this case, is there a way we can get this into just one log? We can. I see logs with the same base, addition between them, so we can use the product rule, meaning we can take the log of x, multiply it by x minus 3, and there we have it. So you can combine logs with the same base through addition by multiplying the insides. So now we have the log of x squared minus 3x equals 1. We can convert to exponent form, so this will be 10 to the power of 1 equals x squared minus 3x. And we have a quadratic, so let's get everything to one side, set it equal to 0, and solve for x. So let's subtract 10 from both sides. we get 0 equals x squared minus 3x minus 10. And now it's set equal to 0, so we factor to solve. So we look for numbers that multiply to negative 10, add to negative 3. So that'll be negative 5 and positive 2. Set each of those equal to 0 to solve for x, and you should get x equals 5 and x equals negative 2. And you could plug those back in, check, use your calculator to make sure they work, and you'd be all set. Okay, number 2, log base 3 of x plus 25 minus log base 3 of x minus 1 equals 3. So in this case, logs with the same basis, so that's good. This time we're subtracting, so that means we divide the inside. So it'll become log base 3 of x plus 25 over x minus 1 equals 3. Let's convert to exponential form, so 3 to the third equals x plus 25 over x minus 1. 3 to the third is just 9. And to solve for x, let's multiply both sides by x minus 1 to get rid of the fraction, so that'll cancel that out there. 9 times x minus 1 will give me 9x minus 9 equals x plus 25, and then we solve for x. So subtract x from both sides to get 8x, add 9 to both sides to get 34, divide both sides by 8, and that'll give us 17 over 4. Okay. Realizing I didn't give myself enough space here. Last one. Again, we have this multiplier here. We also have an exponent. So as we look here, where are we? No exponents. So there's a couple ways we can approach this. We could use that power rule, meaning you bring the 3 out front. So it'd be 2 times 3, so that'd give us 6. Then we divide everything by 6 to get log of 4x equals 2. Convert to exponent form, so it'd be 10 to the power of 2 equals 4x, or 100 equals 4x, which means x equals 25 after you divide both sides by 4. Or you could plug that 3 in. So instead, you'd have 2 times the log of 4 to the third times x to the third equals 12. Divide everything by 2, as well as simplify, so 4 to the third is 64. Equals 6. And then you would convert. So you'd have 10 to the 6th equals 64x to the third, to which figure out what 10 to the 6th is, which it's 10 with, or 1 with 6 zeros. 1, 2, 3, 4, 5, 6. Then you'd have to divide both sides by 64 and take the cube root, and you should get 25. So you have 3 more problems here. These are our last logarithmic ones. So please pause the video, write down those 3 problems, give them a try on your own, and then we'll come back. Okay, I'm back. Pause it again if you haven't written them down, done them already, because here we go. So number 1, the log's by itself, so we can convert to exponent form. So we'll have 2 to the 10th equals x squared over 4. 2 to the 10th, that's got to be a pretty big one. So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1004, 1024. Equals x squared over 4. Multiply both sides by 4. Get x squared equals 4096. Take the square root of both sides. Square root of 4096. That is not one that I know. Let me get on my calculator quick. Square root 40, 96. It sounds like 21 or 22. Oh, no, a lot more than that. Oh, I guess 20 is 400, my bad. 64, okay. Big numbers, still works. Okay, next one. We have logs with the same base added together, so we can multiply those on the inside. So we'll have x minus 2 times x plus 1 equals 2. We can convert to exponent form, so 2 squared equals, and those, I'm just going to multiply these together in the same step. And we have 4 here. Subtract 4 from both sides to get our x alone. Then factor if we can. It factors into negative 3 and 2. Set those each equal to 0 to solve for x, and you should get x equals 3 and x equals negative 2. Last one. Again, we've got this exponent here. So I think it's easier to bring it out front and divide. So we'll have that 3 out front. Divide both sides by 3, and we get log base 4 of 2x equals 2. Convert to exponent form, we get 4 squared equals 2x. 4 squared is 16. Divide both sides by 2, and we get x equals 8. Okay. So that's converting from logs to exponents. All right. So next we're going to talk about solving exponential equations, converting from exponents to logs. If you'd like to pause, take a quick break before we do this, please go ahead and do that. Okay, so when we're converting from exponents to logs to solve, I'll put down some steps here. So the first step is rearrange, simplify to a general exponential equation. What I mean by that is getting it like this. So base to an exponent equals something. So like as we look at this first problem, it's already there. Whereas the second one, that's not the case. We have this plus 8, so we subtracted 8 from both sides. The next one is you take the log of both sides. So notice here we have the log base 5 of both sides. So I chose base 5 because of this 5 here. So the reason we do that is because, if we think about log base 5 of 5 to the x, if you think about the power rule, so that would mean we could bring that x down front. So we have we have x times log base 5 of 5. And the log base 5 of 5, well, that's just 1. So that simplifies to just x. So if you choose your base based on the base here, so that it cancels to 1, that can make it a lot easier to solve. And then we just have the log base 5 of 94. So if there were things to simplify, we would do that. If we could figure out what that was, we would. You see it's going to be a decimal. You can use in your calculator. So if you hit, I'm hitting math, and then it's at the bottom, log base. So log base 5 of 94 gives us 2.829 or 2.82. So you can use that calculator to find it. So again, the way I did that was math, and then if you scroll up, so here's the start. If you scroll up, log base, enter, and then you can enter in the numbers you want. So 5, hit that right arrow, 94, enter. Okay. So the same idea would apply here. So for number 2, we have 3 to the power of x plus 8, so we subtract 8 from both sides. And then we want to take the log of both sides. So I'm going to take the log base 3 of both sides, because then by the power rule, you can bring the x in front, and this log base 3 of 3 cancels. Essentially what happens, in a way, is you could just cancel that out, and you just have x equals the log base 3 of 51, which then you could figure out. So we hit math, up, enter, log base 3, side 51, is 3.58. And there's our solution. So for the next one, again, we don't have it in the general exponential form. so we divide both sides by 3. So 4 to the x is 20. We take the log base 4 of both sides. So again, choosing 4 because of this. And we get x there, log base 4 of 20. So again, math, up, gives us our log base 4 of 20. And that's 2.16. And if you don't know, you have access to this on your Chromebook. It's on the bottom of the Chromebook. There's an app for it, so you can have that TI-84. Okay. Last ones here. And these are the last 3 we're doing. I know it's a long note video, but it's just kind of the way it is. It's some more solving. So here, when we're solving these problems, so let's look at first this one here. So it's set up in our general form, so we can take the log base 4 of both sides, so we can get that x portion down by itself. So that'll cancel there. We have 2x minus 4 equals log base 4 of 64. So we could use the calculator again to solve that, or remember logs. So the way we can simplify this otherwise, log base 4 of 64 equals, basically you think 4 to what power gives me 64? Well, 4 to the third is 64. So the log base 4 of 64 is 3. Or you can still do that log base thing. So log base 4 of 64 also gives you 3. And then it's just a simple equation to solve for x. So we add 4 to both sides. We get x equals 7 over 2. Okay. Next one here. So our goal to start is we want to get that exponential equation into general form. So let's add 2 to both sides first. So we'll get 330. Divide both sides by 4. So we have 9 to the power of 2x minus 3 equals 330 over 4, which gives us 82.5. Take the log base 9 of both sides. So that'll cancel, and we just have 2x minus 3. And the log base 9 of 82.5 is pretty close to 2, but 2.008, I'll round it. Next, we add 3 to both sides, so we get 2 equals 5.008. Divide both sides by 2. And we get 2.504. Okay. All right, last type of problem, this one's challenging. So you'll notice we have variables in both exponents. So when this is the case, we can't just take, it'd be challenging to just take like the log base 243 of both sides, or the log base 81 of both sides, because it doesn't match up exactly. But what I'm noticing is these are both multiples of 3, meaning, so 3 to the 4th is 81, and 3 to the 5th is 243. So I'm going to take the log base 3 of both sides. And you could technically do like the log base 243 or 81 of both sides. Just make sure you do it to both. So when we do this, obviously those variables or the exponents come in front by the power rule. And the log base 3 of 243, well, 3 to the 5th is 243, so the log base 3 of 243 would be 5. And 3 to the 4th is 81, so the log base 3 of 81 would be 4. Now we can simplify. 0.2 times 5 is just 1, so we just have x. 4 times x is 4x. 5 times 4 is 20. Subtract 4x from both sides, we get negative 3 equals 20. Divide both sides by negative 3, and we get x equals negative 20 over 3. That is it. So I know a little challenging. We'll spend some more time practicing this stuff tomorrow and throughout the rest of this week. This is definitely the most challenging target. I know I went kind of fast, so if you need to go back, look through this video, please feel free to do that. You all have a great day.